This video is a record of a class project for the Advanced Machine Learning course at Virginia Tech. The goal of this project was to develop an automated solution to enable spectrum monitoring of wireless systems. A system model consists of two legitimate nodes, which are time-sharing a channel with the same center frequency, but they have different bandwidths. There is a sensor node, which is collecting spectrum information on these two nodes, as well as any jammers that are present in the system. And it passes on this information to a neural network. The neural network detects anomalies as they occur. This neural network was adopted from the PredNet project. We adopted it to detect anomalies in a wireless spectrum. We trained it with an image sequence which corresponds to the normal behavior of our system. And for testing the effectiveness of our approach, we designed anomalies for the wireless system under consideration. These anomalies include a jammer, or the nodes failing, or one of the nodes taking over the channel instead of time sharing. The spectral data from these anomalous events was passed through the neural network, and it reported anomalies as it found them. We're going to follow this slide with a video of the normal functioning of the system. So in this case, we can see that there are two nodes. One has a narrow bandwidth and the other has a slightly wider bandwidth. They're sharing the same center frequency and they're time sharing their channel. On the right, we have the anomaly detector plot. There is a blue line, which is a threshold for anomaly detection. If the prediction error, which is the green curve, goes over the threshold, then we know that an anomaly has occurred. In this case, the prediction error will never go over the threshold because the system has learned this normal behavior and will not detect it as an anomaly. The first anomaly we're going to consider is spectrum hijacking, in which one node takes over the channel. The offending node stops time sharing the channel and starts transmitting all the time. We're going to follow this with a video of what this anomaly will look like, as well as how the anomaly detector acts. So in this scenario, we're examining the node hijacking case. We can see that, like before in the normal functioning, there are two nodes, but there is one node which has started taking over the channel by stopping time sharing, and the anomaly detector has gone over the threshold, which means that we have successfully detected this anomaly. As soon as the anomaly disappears, it will go below the threshold and go back into normal functioning. The next anomaly we're going to consider is the presence of a narrowband jammer. The jammer moves across frequencies but stays in the range of the center frequencies of our legitimate nodes so as to obstruct them. The video that follows will show the functioning of the system in this case, as well as the behavior of the anomaly detector. In this case, we're going to examine the narrowband jammer. You can see that the two nodes are functioning normally on the designated channel. Now the narrowband jammer starts coming in and the prediction error curve starts shifting up towards the threshold. When the jammer is sufficiently present in the spectrum, it will go over the threshold and the anomaly has been successfully detected. As the jammer starts moving out of the spectrum, the prediction error goes down and the system goes back to normal functioning. The next anomaly we're going to consider is the presence of a wideband jammer. It's very similar to the narrowband jammer, but it has a much wider bandwidth, so it obstructs our legitimate nodes much more effectively. The following video will show how the system acts in this case, as well as how well the anomaly detector manages to detect this. In this case, we're going to examine the wideband jammer. You can see that the nodes are normally functioning on the designated channels in this case too. Now the wideband jammer starts coming in and the prediction error immediately shoots up over the threshold. The system can detect it very reliably. As the wideband jammer leaves the spectrum, the prediction error goes down and the system returns to normal functioning. The next anomaly we're going to consider is a network failure, when both of our nodes which were supposed to transmit stop transmitting, and all we see in the spectrum is noise. You'll notice that our detector is not able to handle this case, which is a limitation of our algorithm. The video will display this. So in this scenario, even though both the nodes have stopped functioning, the prediction error does not cross the threshold and a solution is not able to detect this particular anomaly. This is a limitation of our current solution, and as part of our future work, we'd like to improve the neural network architecture to include this scenario as well as be able to work with more complex and practical wireless scenarios. If you're interested in this project, please visit our website, which is linked in the description below.